Hello, my name is Farzin Golzar. I am a postdoc researcher at the KTH Royal Institute of Technology in Sweden. I've been working on this paper in collaboration with Professor Semida Silveira. The topic of this presentation is the implications of improved heat recovery in buildings, a case study of Stockholm. This paper is part of an ongoing project at KTH funded by Formas as a Swedish research council. In this presentation, firstly, I will explain briefly the problem under study. Secondly, the objective and main aim of this paper will be explained. Afterward, the methodology that we have used in order to solve this problem will be explained. And finally, results and main conclusion of this work will be described. Currently, in Stockholm, wastewater from buildings is discharged in the sewage network. So part of heat contents of wastewater is lost, and wastewater treatment plant receives wastewater. Wastewater treatment plant, by a combination of biological, physical, and chemical processes, treats wastewater and discharge treated water to the sea. But before wastewater is discharged to the sea, district heating company recovers heat from treated water by installing centralized heat pumps. So district heating company, by use of this this recovered heat from treated water and other sources of energy, provides heat for city buildings and wastewater treatment plants. However, due to some stricter building regulations, property owners try to find some innovative ways in order to reduce their energy consumptions and reach the aim of nearly zero energy buildings. In addition, emerging new technologies in the case of local heat recoveries encourages people and property owners to install heat exchangers and heat recovery technologies at building levels. So that's the reason we see more and more heat recovery technologies on property levels. So in future, we may see the condition that the amount of local heat recovery on building levels would be upscaled. And in that case, the temperature of wastewater in the sewage network would be decreased, and colder wastewater could affect the performance of wastewater treatment plant and district heating company. So the main objective of this paper is to investigate the impact of upscaling local wastewater heat recovery on the performance of centralized organizations in the city level, for example, wastewater treatment plant and district heating company. In addition, this work may be used as a decision support tools for policymakers to understand the performance of emerging new technologies on the performance of the system. In order to solve this problem, we developed a data-driven model to provide a kind of relationship among different parameters such as ambient temperature, buildings effluent temperature, buildings effluent flow rate, stormwater flow rate, infiltration flow rate, hour of day and day of year, and the temperature of wastewater at the entrance of wastewater treatment plant. So we used the hourly data related to Henriksdal wastewater treatment plant in Henriksdal for the last 10 years and implemented artificial neural network to train data and develop the model. In order to validate and investigate the performance of the model, we compared the simulated data and observed data for year 2019. As statistical indicators show, there is a good agreement between simulated and observed data. For the aim of considering local heat recoveries, we considered heat exchangers as local heat recovery technology as passive heat recovery technology, which is suitable for preheating cold water. The amount of wastewater temperature drop in heat exchanger depends on different parameters such as physical properties of heat exchangers and temperatures and flow rates of wastewater and cold water into the heat exchangers. And a range of 2 to 13 degrees centigrade is reported in the literature. So we assumed an average value of 5 degrees centigrade as the wastewater temperature drop in the heat exchangers. And also we assume that in future, 10%, 12%, and 40% of buildings connected to Henriksdal wastewater treatment plant would install heat exchangers for the aim of wastewater heat recovery. So in this figure, you can see the amount of heat loss in the sewage network. A red line shows the amount of heat loss in the sewage network for current situation without local heat recovery. But in the case of local heat recovery, the temperature of wastewater in the sewage network would be decreased. So the temperature difference between wastewater in the sewage network and ambient temperature is decreased. So as figure shows, this difference, this temperature difference between wastewater temperature and ambient temperature would lead to 230 gigawatt hour per year less heat loss in the sewage network in the case that 40% of buildings use heat exchangers as local heat recovery. On the other hand, local heat recovery would cause some consequences on wastewater treatment plant. For instance, wastewater treatment plant demands heat for warming up the temperature of sludge from wastewater for the aim of digestion. So in case that, in case of local heat recovery, the temperature of wastewater is decreased. So wastewater treatment plant demands more heat. And in case of installing 40%, installing heat exchangers in 40% of buildings, 0.71 gigawatt hour per year, more heat wastewater treatment plant would need for the aim of warming up sludge in the wastewater. Moreover, the amount of available heat for recovery in district heating company level would be decreased. In this figure, a red line shows the amount of available heat for recovery in treated water by district heating company in current condition is presented. But in the case of local heat recovery, 176 gigawatt hour per year less heat is available for heat recovery. But on the other hand, local heat recovery would cause 96 gigawatt hour less heat demand in buildings. So generally, district heating company may need to compensate 80 gigawatt hour per year deficit heat. So the developed model in this work is able to investigate the impact of different local heat recovery technologies like heat exchangers and heat pumps, and also the impact of different percentages of buildings which are using local heat recoveries. But in this presentation, we presented the impact of installing 40% of heat exchangers on buildings. So in the case of heat recoveries by heat exchangers in 40% of buildings, we saw that the amount of heat demand in building is decreased by 6%, and 60% of heat loss in the sewage network will be decreased. But on the other hand, the amount of heat demand in the wastewater treatment plant will be decreased by 6%, and the amount of heat recovery in district heating company will be decreased by 11%. So it shows that this kind of changes on a local level would lead to some disruptive impacts on the system level. This work shows that these types of disruptions would lead to some significant economic implications on centralized organization and affect their business level. And this kind of changes would lead to change of prices of water and energy provided for consumers. Therefore, it is important that regulators and policymakers be aware of this kind of risks associated with emerging new technology in order to put incentives or imposes for emerging innovative and new technologies. And the developed model in this work may be used as a kind of decision support tool for policymakers in the case of wastewater heat recovery. And finally, I would like to finish my presentation by saying from Chef Seattle, who says, "We don't inherit the earth from our parents. We borrow it from our children." Thank you for your attention.